Welcome you all for this online NEET classes. In this class we are going to discuss about organic chemistry. See, whenever you study organic chemistry, students be more specific that now I am learning all the classifications in organic chemistry, like what is aromatic compounds, anti-aromatic compounds, non-aromatic compounds, what is aliphatic compounds, how it will be classified. And second, you start learning all the IUPAC nomenclature concepts. And third, you try to learn all the isomerism. These three things we'll call it as GOC, General Organic Chemistry. Whenever you study reactions, before you study General Organic Chemistry, complete all the classifications, complete all the IUPAC nomenclature content, and complete all the isomerism. Now come to reactions. Whenever you learn any reactions, be more specific. Try to remember the name of that reaction, either scientist name or the type name. For example, suppose whenever I write a reaction, try to remember it is Gattermann-Koch reaction, it is a Riemann-Tiemann reaction. So try to remember the scientist name. If you don't remember the scientist name, at least you try to remember the type name. Maybe you can ask me what are the type name. I told you already, okay, the type name is, it can be a substitution reactions. It can be a substitution reactions. Maybe more specifically in substitution reaction, you can say it is a nucleophilic substitution reaction, or you can say it is an electrophilic substitution reactions, or you can say it is a free radical substitution reaction, and you can say it is an addition reaction or elimination, addition elimination reaction, or you can say it is a redox reaction, or you can say it is a redox reaction. So whenever you learn any reaction, just go for that reaction. Try to remember the name of the reaction. Either if you remember the scientist name, go for the scientist name, or at least mandatory you have to know the type name. It is an addition reaction or substitution reaction or redox reaction. Then what are the reagents used in that reaction? That is more specific. Okay, what are the reagents used in the reaction, and you have to know what is the role of that reagent and what is the limitations, any limitation there for that reaction, that you have to know it. Then fifth topic, you have to go for physical properties based question. Generally we'll call it as reasoning based question, like boiling point, melting point, solubility, volatility, dipole moment, and we are going to discuss some questions based on acidic strength, basic strength. And sixth topic is applications, uses based questions. You will be getting questions from polymers, chemistry and everyday life, all those things. Then last content is practical organic chemistry. These are the 7 topics you have to be very thorough if you prepare for any competitive examination. Let me recap it. First one is classification based question. Second one is IUPAC nomenclature based question. Third one is isomerism based questions. And reactions, this is very important. Reactions, whenever you learn any reactions, please try to remember the name of that reaction, specifically scientist name, or you have to know the type name and what are the reagents it is being used and what is the role of that reagent, any solvent has been used, and you have to know the limitations also. If this type of reaction, it can be either substitution reaction, nucleophilic substitution, electrophilic substitution, free radical substitution, or it can be an addition elimination reaction, or it can be a redox reaction. And fifth topic is you have to be very clear with the physical properties, and sixth topic is uses or application based, and seventh topic will be practical organic chemistry. Now this session I am going to explain specifically electrophilic substitution reactions. Now we'll go for electrophilic substitution reaction. Okay, now electrophilic substitution reaction. Generally aromatic compounds will undergo electrophilic substitution reaction. Since aromatic compounds are electron rich compounds, so they can undergo electrophilic substitution reaction. Aromatic compounds, the most famous example which we are going to take is benzene. So benzene can undergo electrophilic substitution reactions. I am going to explain all the type names, types. First let me explain all the basic reactions comes under electrophilic substitution, and we'll go for other reactions. First one is, we'll say nitration reaction, very important, nitration. And second one is, we are going to learn halogenation, maybe like chlorination, bromination. If it is iodination, I am going to give some criteria for that. And third reaction is sulfonation reaction, and fourth one is Friedel-Crafts reactions, And fifth one is in electrophilic substitution reaction. I am going to be more specifically, one important classification is electrophilic insertion reaction. In that we are going to discuss some naming reactions. And sixth one is very specifically we are going to learn about benzene mechanism. Actually it is not electrophilic substitution reaction, it is a kind of nucleophilic aromatic substitution, but still we are going to discuss under benzene compounds. Now we'll take nitration. I'll take benzene, and you know that benzene is an aromatic compound and all are sp2 hybridized carbon, and I'm going to replace any one of this hydrogen in this benzene compound. Let me take nitration. First example, I'll take nitric acid and sulfuric acid, concentrated nitric acid and concentrated sulfuric acid, and this we'll call it as nitrating mixture. We'll call this as nitrating mixture. Now HNO3 will split as NO2 plus and OH minus. Now this is going to be my electrophile, and sulfuric acid will be acting as a catalyst for this reaction. Now this NO2 plus will go and substitute H plus, and I'll get nitrobenzene. That H plus will go and react with this OH minus to form water. This is nitration reaction. Now I'll give you one more example. Take same benzene, treat with Br2. Treat with Br2 in presence of FeBr3. This will act as a catalyst, and this is Lewis acid. And you know what Lewis acid will do? Will take this negative anion, so it will create an electrophile and it will become FeBr4 minus. Now students, I got the electrophile, right? This electrophile will go and substitute this hydrogen. So you will be getting bromobenzene, and that H plus will come and react with that remaining Br, and you will remove the catalyst. This is bromination reaction. Let me do sulfonation reaction. I'll treat with concentrated sulfuric acid. In textbooks they'll use oleum. Oleum is nothing but H2S2O7. It's nothing but concentrated sulfuric acid, and the electrophile is going to be H2SO4 will give you SO3, and this will be my electrophile, and this electrophile will come and substitute here. So you will be getting SO3H. These are the three basic reactions in electrophilic substitution reaction. Now I'm going to go more specific for Friedel-Crafts reactions. Let me discuss Friedel-Crafts reactions here. I'll take benzene. It is Friedel-Crafts reactions. It can be alkylation and acylation reactions I am going to discuss. Students, now take benzene, treat with any alkyl chloride in presence of anhydrous AlCl3. As you know what, AlCl3 is a Lewis acid. It will try to attract Cl minus anion, so it will split as R plus and AlCl4 minus. Now you know this is your electrophile as usual. In this case NO2 plus is your electrophile. In this case SO3 is your electrophile. In this case Br plus is your electrophile. Now in this case R plus is your electrophile. This electrophile will go and substitute to get alkyl benzene plus HCl. Let me do Friedel-Crafts acylation reactions. Here I'll take example acyl chloride. It is not like mandatory I have to take only acyl chloride. I can take even anhydrides, acid derivatives, acid anhydride. On treatment with anhydrous AlCl3, again this is a Lewis acid here, and it will take your anion and you will get RC double bond O plus plus AlCl4 minus. And students, don't forget, whenever you use any Lewis acid, it is not mandatory that you have to use AlCl3. Since Friedel-Crafts reactions we are using AlCl3, you can use even BF3, etc. Any Lewis acid you can use. See here we have used FeBr3. So whenever a Lewis acid is there, this Lewis acid will remove that anion part and it will create an electrophile. This electrophile will go and substitute. So you will be getting C double bond O R. This is Friedel-Crafts acylation reactions, and we are going to discuss many important concepts in Friedel-Crafts acylation reactions. Okay. Now I'll take benzene. Let me discuss few examples. In alkylation, generally we might have been saw some reactions in your textbook. Maybe they'll take an ethyl chloride on treatment with anhydrous AlCl3. You will be getting toluene, right? You will be getting toluene. Now instead of this normal or simple alkyl, we are going to take some complicated alkyl group and we are going to discuss what are the important products is being formed. That is going to be very important for your competitive examination. Just now you can copy down this. I'll give you 2 minutes time and we will go and discuss in depth with Friedel-Crafts reaction. Okay, sir? 10 Kadir. Yeah, students. Now we are discussing about electrophilic substitution reactions. As I told you, aromatic compounds will undergo electrophilic substitution reactions, and we were discussed nitration reaction, sulfonation reactions, halogenation reactions, Friedel-Crafts alkylation and acylation reactions. Now we are going to discuss some more important examples of Friedel-Crafts reactions. Now I'll take benzene. Now treat with some different alkyl group. Example, we'll take this alkyl, we'll take this alkyl group in presence of anhydrous AlCl3. Now what students majority they mistake they'll do as usual, they'll imagine this is our R part as usual and this is Cl. So on treatment with anhydrous AlCl3, they'll remove this and they will try to form this electrophile and they'll substitute it. So you will be getting this compound CH2, C, CH3, CH3, CH3. Students, still since we are doing all these things in an online, If you have any technical issues, be patient, we'll rectify it and we'll try to do it. Now, we'll come back here. So benzene, this on treatment with this, majority will write this as your product, but this is not your product. Please understand one thing, the carbocation which is being formed here is primary. Whenever in any reaction, if a carbocation is being formed, please check for any rearrangement possible to form more stable carbocation. As we know that tertiary carbocation is more stable than secondary, is more stable than primary. Now I am going to check first, is there any possibility to get any stable carbocation. Now if I migrate this methyl group here, I will be getting CH3, CH3, CH2, CH3. Now this is my tertiary carbocation which is more stable compared to primary carbocation. So automatically this methyl group will migrate there. This methyl group will migrate to form tertiary carbocation. Now tertiary carbocation formed, this will go and substitute. This will go and substitute. So you will be getting CH3, CH3, CH2, CH3. Okay, what is the IUPAC nomenclature of this compound will be? We'll do numbering it. 1, 2, 3, 4. So it will be 2-methyl 2-phenyl-butane. This is going to be your root word. Okay, now we'll do some more examples. We'll take benzene. Similarly, now you will be knowing it. I'll treat with N-propyl chloride in presence of anhydrous AlCl3. As usual, what we expect? We expect to write like this, right? CH2, CH2, CH3. Please don't make that mistake. Now what you do? First to form carbocation. CH3, CH2, CH2 plus and AlCl4 minus. Now check for any rearrangement is possible. Yeah, this is primary. Now what I am going to do is, I am going to transfer hydride ion, H minus shift. H minus shift from here I am going to do it, so that it is become CH3, CH plus CH3, which is secondary carbocation. As you know that, okay, tertiary is more stable than secondary, is more stable than primary. Always check for stability of carbocation. Now this will go and substitute to form CH, CH3, CH3. So you will be getting isopropyl benzene as the product. Please don't forget this. So this one thing I just want to mention is, whenever you are doing Fidelcraft reactions, please always check for the stability of carbocation. So you have to migrate. Maybe I'll give you one more example for this. I'll give you an example of a nucleophilic substitution reaction, SN reaction. So like same example, I'll take it, CH3, 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 CH2Cl. We'll call it as neopentyl chloride. Now this on treatment with say aqueous KOH. Generally students, they know that if it is aqueous KOH, it will go for nucleophilic substitution reaction. Immediately they will remove this Cl minus and they will substitute OH. So they will expect this product CH3, 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 CH2OH. Please don't make that mistake. Again, check for the stability of carbocation. So you will be getting CH3, CH3, OH, CH2, CH3. So guys, this will be your major product, not this, because there will be a rearrangement. Even if you do an elimination reaction, okay, you just work it out for an elimination reaction and check what product you will be getting it. Please don't go for the product with this one, CH3, CH3. As usual, this will be your chlorine, and you can't go for a beta elimination there. Okay, so there will be a rearrangement occurs. After rearranging it, you will be getting double bond CH and CH3. Got it? This methyl group will be migrated there, then you will go for elimination reaction, beta elimination reaction. So let it be an elimination reaction or let it be a nucleophilic substitution reaction, for example like specifically SN1 reaction, or it can be a Friedel-Crafts reaction. Wherever a carbocation is being formed, please check is there any possibility to get stable carbocations, because in competitive examination they will give you what happens when benzene on treatment with N-propyl chloride in presence of AlCl3. They will give you 4 products. So you please work it out and check what is your major product. Now we will go for few more reactions based on Friedel-Crafts reaction. Friedel-Crafts reactions. Whenever I discuss Friedel-Crafts reactions, I have to tell you these 2 points. First, there will be very famous question in your CBSE textbooks, why benzoic acid will not undergo Friedel-Crafts reaction. Why benzoic acid will not undergo Friedel-Crafts reaction. In that text, they might have been explained that since benzoic acid is a deactivating group, since it is, you know that it is a -R group and it is a deactivating group, all those things we might have been learned in general organic chemistry. Since benzoic acid is a deactivating group, generally Friedel-Crafts reactions will be very slow for the deactivating groups, or we can say reaction will not be possible. So benzoic acid will not undergo Friedel-Crafts reaction because it is a deactivating group. Now, maybe one more example is aniline. But now you can come to an argument that aniline is an activating group and it is a +R group, but still you might have been studied that aniline will not undergo Friedel-Crafts reaction. The reason here is there is a reaction happening. The reaction is this AlCl3, since it is a Lewis acid and this aniline is going to be a Lewis base, there is maximum probability of salt formation occurs. Once the salt has been formed, it will lose the lone pair of electron and will become an anilinium concept, which is a meta-directing, and it is a deactivating group. Again, I told you Friedel-Crafts reaction will be dead slow for the deactivating groups, okay, or with using thermodynamics we can say that reaction is not possible, or with kinetic explanation we can say the reaction is not possible. So this is electrophilic substitution reactions. Now I'll just recap what I have done it. This class we are discussing about organic chemistry. Students, whenever you learn organic chemistry, be yourself more specific that what content you are preparing it. Either you are preparing from IUPAC nomenclature. If you prepare IUPAC nomenclature, read all the rules and take some MCQs and practice all those things. Now we are discussing about reactions. In reactions specifically, today in class I have taken electrophilic substitution reactions. I told you aromatic compounds will undergo electrophilic substitution reaction because it is electron rich substance, one thing, and the famous example for aromatic substances I have taken benzene, and I was discussing some examples like nitration reaction, sulfonation reactions, halogenation reactions, specifically chlorination and bromination, and Friedel-Crafts alkylation and acylation reactions. In Friedel-Crafts alkylation acylation, other than methyl group, if they give you some other different alkyl groups, okay, I've taught you what you have to do. Always check for stability of carbocation. Not only here, even in nucleophilic substitution reactions also, even in elimination reactions also, please kindly check is there any possibility of rearrangement of carbocation. Go for more stable carbocation. Even this concept is applicable. Okay, let me give one more example. It is not Friedel-Crafts reaction, but we are going to use same catalyst. I am going to say that as Fries rearrangement reaction, since it is a similar kind of reaction. So let me take phenol. Let me take example phenol. Students, I want to understand here one thing is, take phenol, treat with, I am not going to do Fries rearrangement, I am going to do first Friedel-Crafts alkylation, treat with CH3Cl in presence of AlCl3. You know, since phenol is an +R group and the product which you expect is OH CH3 in the ortho position, which is going to be your minor product, and CH3 in the para position, which is going to be a major product. This you know why. Now, before detailedly explaining about Fries rearrangement, I'll do even Friedel-Crafts acylation also. Now treat with CH3 C double bond O Cl in presence of AlCl3. Already I told you what is the role of AlCl3. AlCl3 is a Lewis acid. We'll try to take this anion and you will get an electrophile that will come and get substituted in para position, which is your major product, C double bond O CH3. You got it? Now this is normal Friedel-Crafts reaction. Now what we are going to discuss for Fries rearrangement is, what is Fries rearrangement, that you have to know what. In Fries rearrangement, you know what is Cotton-Bowman reaction. I'll take sodium phenoxide ion, I'll treat with CH3 C double bond O Cl. You know it is an esterification reaction where this O minus is going to substitute this Cl minus. So you will end up with O C double bond O CH3. Students, I just want to compare three reactions now. One is normal, this reaction, which I am going to make a box. This is normal Friedel-Crafts acylation reaction. And here, which I am going to do is esterification reactions, and the name of that reaction is Cotton-Bowman reaction. In this, you got this product. We'll call that as phenyl ethanoate. Now what is Fries rearrangement is, the phenyl ethanoate, if you are going to treat with anhydrous AlCl3, you are going to get the product which is being formed when phenol is treated with Friedel-Crafts acylation reaction. Hope you will be understanding it. See, I'll again explain once again. Now take phenol, do Friedel-Crafts acylation, you will be getting this as your product. Yeah, right? The same product will be formed when phenyl ethanoate is treated with anhydrous AlCl3. This is called as Fries rearrangement. Thank you, students.